Hi, everyone. Welcome to my talk today on Spinnaker Extensibility, a journey. Who am I? I am Cameron Motevasselani, a software engineer over here at Armory. I've been a Spinnaker contributor for about the past 2 years, and I'm a co-lead on the Spinnaker Platform Special Interest Group. We meet every other Thursday at 11 a.m. Pacific time. My contact information is at the bottom of the screen. You can find me at cameron@armory.io on email and on open source Slack at Cameron Motevasselani. So let's talk about our agenda for today. We're going to be talking about Spinnaker and Spinnaker extensibility. You may have seen some talks of mine in the past on plugins in the plugin framework, and we'll be talking a little bit about that today. But we want to show you the journey we took to getting to the plugin framework. We'll go over how we've extended Spinnaker in the past via the JVM, a few different stages that have been added over the years to help with extending Spinnaker, and then we'll talk about the plugin framework and future plans. So before plugins, everyone extended Spinnaker via the JVM. So what does this mean? If you check out this blog post linked here, you can read up on how Netflix extends Spinnaker, and many other organizations extend Spinnaker in the same way. What way is this? Well, Spinnaker itself is made up of 9 to 10 Java microservices. These are all Spring Boot apps. In each application, it's comprised of a few different packages, many different packages in some cases. These packages are published as jars, and you're able to pull these packages in and layer your own code on top of it. This is pretty standard for Java and Spring Boot developers, so it's a pretty great way of extending Spinnaker. Why would you want to do this? You might have some custom functionality that you want to add. This functionality may not be relevant to the rest of the community, so you want to keep it just for your organization. You might also want to fix some CVEs that are present in the open source packages. CVEs are found every day, so while an image might be scanned or a package might be scanned, and there might not be any images today, you can scan the same image tomorrow, and if there's a CVE for that image, you now have a vulnerability on your hands and might want to patch it and not wait for the next release to get the update. Now, do people still extend Spinnaker in this way? Yes, they do. We do it over here at Armory ourselves. We would like to move on to just using the open source plugin framework and getting off of our own distributions. We believe that improving the community is the right way of going. There's custom webhook stages defined in configurations. Let's take a look at what this looks like. So a custom webhook stage is a way for Spinnaker operators to add a native looking stage within their Spinnaker installation. So if we look at what that looks like, we can check out this custom webhook stage here. This stage updates a GitHub commit status. So in your configurations, you're going to have this YAML that describes the stage that will update a GitHub commit. This is what it looks like within the UI. So again, as an operator, I can hook into services that my team runs. This might be a central DevOps team that provides certain services like getting authorization keys for different accounts, etc. This is really nice because it shows a native stage to the Spinnaker users. When they go and create pipelines, you'll have a dropdown and there will be your custom stage. There's also this run job manifest stage, and this is defined on a per pipeline basis. Let's take a look at what that looks like. There's some great documentation online at spinnaker.io, and if you check out the guides, there's this run job manifest doc. It has a lot of information about run jobs, but this blog post that is linked here, I found to be very helpful. If we scroll down and take a look at what a manifest looks like, this is a manifest for building a Docker image and pushing it to Docker Hub. It also will clone the source code for a particular repo. As you can see here, it's essentially a Kubernetes job. You specify containers, volume mounts, commands, etc., in order to describe your stage's functionality. In the end, you essentially will copy and paste that into the UI. I believe you can also specify an artifact that will do this as well. So run job manifest stages are geared towards application developers. They can write Kubernetes jobs to do what they need to accomplish. That might be hitting another service to tell it that a deploy has happened or failed, or whatever you want to do. This is hard to share across an organization. Why is that? Well, you might write a manifest that you want to add another parameter to. Well, now you have to go to every pipeline that uses that run job manifest stage and update it accordingly if you want to share those best practices or updates. This turns out to be a really hard and laborious task. Finally, there's custom job stages. And this is a pretty nice way of adding functionality to Spinnaker where you share it across your organization. It's similar to a run job manifest where you provide an image and a command to run. But this is shareable across your organization. So similar to a custom webhook stage, it's defined in your Spinnaker configs. And similar to a run job stage, it is like a Kubernetes run job. Kubernetes job, apologies. Great, so as a Spinnaker operator, I can define best practices for my organization. This is a lot better. It's not just a webhook. It could be a webhook, but it's not just a webhook. You can use any container you'd like, and it has a native feel. So what else would I want? That sounds pretty great. I'm a Spinnaker operator and I can share best practices across my organization in a native way. Well, there's some missing features and functionality. You're sharing best practices within your organization, but you're not sharing best practices with the community. That's, in my opinion, one of the advantages of working in open source is there's a lot of smart people and they like to talk about and share best practices with each other. Codifying those best practices and then sharing them around is a great thing to do. In addition, there's not really any standardization. Like I mentioned earlier, you might write a run job manifest and then tweak it over time. If another team uses that same run job manifest and tweaks it on their own, well, you can have some divergence there. There's no versioning or anything associated with this as well. So if you want to make a change, well, have fun doing that. You also can't discover any of these stages. There's no central repository for discovering what custom stages or images and all their associated parameters around. So you have to essentially spread by word of mouth or come up with your own solution for discovering custom stages within your organization. The speed at which features can be delivered has been good, but also slow. We must wait for a new Spinnaker release, which happens every couple months, and that's when new features are released. There's, of course, patch releases along the way that include fixes, but there's no new features accepted into previously released branches. So getting a new feature might be 2 months down the road, it might be 3 months down the road, depending on the speed at which you develop the feature, and then when it gets into the code base, and then when the release is actually done. In addition, if you want to get a new feature, you have to upgrade to that new version. That new version might have bugs. It might have other breaking changes that you're not ready to use. There's a pretty high barrier of entry as well. You have to know quite a bit either about Spinnaker, if you're extending via the JVM, or if you're writing a run job manifest stage, it's quite a bit of effort. It's easier if you're used to Kubernetes and defining manifests and running jobs. However, many people are not used to that. We would also like to make it so that the maintenance cost of extending Spinnaker is lower. Custom job stages, pre-configured webhook stages, and run job manifest stages all have a high maintenance cost. So after plugins, our plugins MVP, I've linked to the original RFC in the slides. And this was a pretty true to the name MVP. This was a very MVP solution. So this on the right is a nice diagram of how products are built over here at Armory, rather than saying, hey, I want a car, and then rather than building a wheel and then building 2 wheels and then building 3 a wheel in the body, and then finally having a car at the end, like that's very waterfall. That's very not usable. You don't have anything usable until you're done with the whole product. Really, we want to figure out what the requirements are and provide some value at every stage of the journey. So the plugins MVP, we said, hey, we want to extend Spinnaker in better ways that are not quite tied to the code base. How can we do that? Well, if we add jars to the class path, again, this was done via the code base, and we had to wait for a release for this. Once the release came out, you could add jars to your class path, and Spinnaker would load them up at startup time, and you'd be off to the races. This was very error prone. You could fall off, similar to the skateboard. You could fall off and hurt yourself and not have a great time. Even with all these rough edges, people were still interested. We just had a skateboard, but people knew it could take them places. And they're interested in getting the bicycle or the motorcycle, or really they want the car. So we noticed people were interested and said, okay, let's double down now and create a full-on framework. During this time, we created the platform SIG. The platform SIG is in charge of extensibility as well as build, test, and release. So out of conversations in the platform SIG and talking with other core contributors, we quickly identified many issues with our MVP. There were no metrics or events coming out of Spinnaker, so you don't know exactly what was loaded, what was not loaded, whether there were any failures or errors. In addition, there was a low quality of life for plugin developers and Spinnaker operators for the plugins MVP. Thankfully, there weren't too many, if any, plugins in production during that time, but now we've added a bunch of things to improve the quality of life. So the missing features I mentioned earlier around versioning, metrics, etc., All of that has now been added in this V1 framework. So we've had a lot of quality of life improvements for Spinnaker operators. They can now manage plugins and their versions and configurations via the Spinnaker config. And we've made a lot of quality of life improvements for plugin developers as well. We've added extension points within Spinnaker, which are long-term stable contracts, API contracts that plugin developers can code against and have confidence that their plugins will be stable for a long time. This allows plugin developers to write against simple contracts, and it also allows for core contributors to improve the core code base without breaking all the plugins. I've linked the plugins V1 RFC, as well as the framework that our plugin framework is based on, PF4J. PF4J is the framework that brought in the idea of extension points and will continue to play a big part in our plugin framework. So how do you write plugins? Well, PF4J has a nice way of essentially writing Java code that matches an interface, that interface or extension point. They're very similar within the code base. This is great if the work has been done beforehand to create extension points. But as we're just starting with the plugin framework, there weren't any of these extension points at first. So we added the ability to create Spring-based plugins. So very similar to extending Spinnaker via the JVM, you can extend Spinnaker via Spring. In our plugins V1 framework, there were a few changes we had to make so that you could use Spring annotations within your plugin. It's not quite one-to-one with Spring. There's a little bit of extra functions you need to call in order to register your beans and scanning certain packages, but you're able to do it. During this time, we created the plugins working group, and this is essentially the core plugin framework developers. We meet every Friday at 10 a.m. Pacific time and talk about plugin framework improvements, extension points that are interesting or that we've seen a lot of asks for, and just general improvements. So why is plugins V1 so awesome? It uplevels the people that are creating plugins from application developers and Spinnaker operators. It is now service providers creating plugins that will share best practices for interacting with their services amongst the whole community. What does this mean? Well, if you want to add another, let's say, cloud provider to Spinnaker, you may want to write it as a plugin and codify best practices for deploying to your cloud in your plugin. Before this, if you wanted to add certain functionality and share best practices, you had to get your code into the core code base and then maintain it. This led to some stages being added to Spinnaker that were not maintained and have been sitting around broken for a while. We're now in the process of ripping unused and broken code out and looking to improve the code base. So plugins V2 was released in the latest release of Spinnaker, so 1.23. So what was wrong with V1? Well, as I mentioned before, it wasn't quite springy enough. There was a few things that you had to do to enable a good Spring experience, Spring development experience. There were also a couple bugs. In Orca, if you were using a custom stage plugin that used our plugin SDK, you'd have a bad time. These are all fixed now in the plugins v2 framework with minimal changes on the plugin author side. Minimal or no changes on the plugin author side, depending on what type of plugin you have written. Essentially, what we've done is changed how plugins are loaded into the services and are going to be standardizing on how they register and are used within the services. Again, this is based on PF4J, and as I said before, it provides a better experience for Spring developers. This also comes with some configuration improvements. Rather than having to define all the extension points used and their specific configurations, you now can add configurations on a per plugin basis, not per extension point. So we have a bunch of stuff as a work in progress, as well as future plans for improving the framework and the ecosystem around extensibility. Right now, we're working on plugin compatibility improvements. There's a lot of different versions going around with Spinnaker. There's service versions. There's Spinnaker release versions and more. So we're working on ways of tying all these together. So given a version of Spinnaker, you'll know which plugins are compatible with that. We're going to be piping that information into a plugin marketplace, which is technically up and running. However, it's empty right now. But eventually, every Spinnaker will have the open source plugin marketplace or plugin hub. No solid term for that yet. We're going to be having every Spinnaker installation have that as a default repository. So you'd be able to utilize plugins that have been open sourced by the community. We're going to be adding more extension points. So this will continue to improve Spinnaker and its foundation. We're also going to be improving the plugin configuration and delivery flow. Right now, configuring plugins for Spinnaker there's a couple different ways of doing it. You can do it the easy way, which does have some performance implications. For instance, if you add a plugin to a Spinnaker installation, all your services will restart. There's ways around this, but you have to take a little bit more time and thought into figuring that out. We want to provide tooling so that this is all automated. In addition, we want to be able to deliver plugins to you easier, and that goes towards the plugin marketplace I mentioned earlier. Finally, we're working towards this idea of a lean core and expansive ecosystem. So what this means is creating more extension points and ripping out code that's in the code base. You can think of things like artifacts or cloud providers or event listeners as targets for converting to extension points. Once this is done, you can then pick and choose essentially what is loaded into your Spinnaker installation, which will then mean for a smaller services that you're running, as well as less surface area for bugs and CVEs. If you're interested in helping out or learning more, please join us at the plugins or platform SIG channel in open source Slack. I hope to see you there.